In this video, we are going to go over how to do the plate tectonics simulation so you can follow along with your worksheet. Number 1 says in the lower right corner, check Show Labels box and set the view to both. Use the slider in the top right corner and slide it down to zoom all the way out. Okay. List the layers of Earth's interior from top to bottom, the top being the crust, all the way down to this label here. Use a thermometer to measure the temperature of Earth's layers. Click and drag the thermometer onto the layer you're measuring. Which layer is hottest and which is coolest? So here we go. We can see the temperature of the crust, the mantle, the lower mantle, and notice that it has filled up one thermometer already, and now there is excess in this second thermometer. The outer core, and the inner core. What pattern do you notice regarding the temperature of the layers? Use the density probe to measure the density of Earth's layers. Which layer is most dense and which is least dense? What pattern do you notice regarding the density of the layers? So we're going to use our density gauge here. Here we have the crust, mantle, lower mantle, and notice that one whole gauge has already been filled in a portion of a second. Outer core and the inner core. Zoom back in on the crust. Click and drag the density gauge onto the crust. Then use the sliders to change the temperature of the crust. How does changing the temperature affect the density? Here we have warm. Here we have cool. At what temperatures and densities does the crust float up, and when does it sink down? And this is a very subtle change. So focus on the movement in this area. We're going to set the temperature to the middle. We're now going to focus on composition. How does changing the composition of the crust affect the density? So we're going to increase silica. Now we're going to increase iron. When does the crust float up? When does it sink down based on composition? So more silica, more iron. Use the slider to change the thickness of the crust. How does changing the thickness of the crust affect the density? At what thickness does the crust float up? And when does it sink down? For number 5, you're going to say, how can you tell if the crust will float or sink based on the density? So use questions 2, 3, and 4 to help you with that. I'm going to continue on. You can pause if needed. Adjust the settings to get your crust to perfectly match the oceanic crust. Once you have done this, describe the temperature, composition, and thickness settings that were required. So we're going to try and match this oceanic crust over here. Make it thinner. Maybe add a little more iron. Looks like we got to match the color of the temperature. I think that looks pretty good. So pause here and describe the temperature, composition, and thickness of the oceanic crust. For number 7, adjust the settings to get your crust to perfectly match the continental crust. Once you've done this, describe the temperature, composition, and thickness settings required. So we are going to increase There we go. Let's take a moment to describe the temperature, composition, and thickness of the continental crust. Following this simulation, you're going to write a minimum of 3 sentences summarizing what you have learned from the simulation regarding density and the movement of Earth's crust using the provided terms.